Thank you very much. Okay, thank you everybody for coming along to the first Open Code Garden episode of In the Code Garden. Yeah, today it's going to be a very casual session. When we don't have extra questions, I'll just be going through a module on Microsoft Learn, and we'll just be practicing some Python basics and some cool algorithms as well. But feel free to ask any questions about Python at any point. I'm happy to go on a little detour to talk more about a specific function, of Python, some specific syntax, or any, interesting tips that I can give you from my perspective of like how I might do something differently. So yeah, please ask any questions in the chat anytime. I can see your chat here on my left all the time. So I hope I'll catch them all. But yeah, I also would love it. Yeah, if you jump in, if you want to ask your questions over audio when I open up the question time, that'd be awesome. Or come on camera, because it's nice to actually get to see all of my code gardeners around the world, because normally it's just me talking into the stream that comes to you on YouTube or Twitch. So yeah, but let's get started. So yeah, this is our early morning show. If you really like this, you can come again in 7 hours time from now. And yeah, today we're going to be practicing Python with Caesar ciphers and just answering any Python questions that you have or related to Python questions. I'm not going to lock it down to only Python, but I don't know about every part of technology, so I can't answer every single question that you might have. Yeah, and today for our gardening tools, we'll be using Visual Studio Code. You might want to use the in-browser version on github.dev or via visualstudiocode.dev. Lots of options. Oh, I've just got the installed version on my computer. We'll be using the Python extension because we're doing Python, and I'm going to be using Jupyter Notebooks just so I can show you all the different steps along the way. You don't need to use Jupyter Notebooks, you can just use a regular Python file, but good so we can, I can push all of the content later to GitHub so you can see all the steps that we did. Yeah, so what are we going to be doing today? We're looking through this Microsoft Learn module that Sarah has posted in the chat above. So you can click on that one to get to the module that we'll be doing today. And this is about cracking codes and revealing secrets with Python in Visual Studio Code. So if you haven't already got Visual Studio Code installed and you want to install it on your computer, you can go to this second link, the one that ends in training path Python 1, down the bottom that I've got here. And Sarah's posted that as a second link in the chat as well in her message. Yeah, and we'll be writing some code, creating functions in Python. So that's a really handy tool if you haven't made a function before. And then talking about some, encryption, low-key encryption solutions dating back to the Second World War. So you've got some stuff there that you can, maybe it sparks your interest in cybersecurity. Who knows? Okay, and we'll get to decipher what this hidden message is, which is what we'll get to in the first moment. Okay, so I'm going to put this thing up on the screen first, actually, so we can see what we're doing. Okay, cool. So if you haven't been to Microsoft Learn before, it's super handy to learn a bunch of stuff. Let's actually open it up and see all the stuff that we can learn in here. So all kinds of resources around for certifications and documentation on all the different things you might be doing, whether it's using technology or building technology. And this is one of the modules in the training section. And you can look up all manner of things in there. So I can highly recommend it. I didn't actually know about this until I was interviewing for Microsoft, and it's just super handy, whether you're learning to code or you're learning Microsoft specific technology. So can recommend. So what are we actually doing today? I've shown you this in the screenshot already, and we need to have Visual Studio Code installed. And there's a number of steps along the way that we'll be doing. So we're going to, reading the introduction. Fantastic. And yes, but actually, I haven't actually written any of this code from this module before. I happen to have written similar code in the past when I used to teach children to code. But yeah, I never actually introduced myself. I'm Renee Noble, Regional Cloud Advocate for the Microsoft Reactor here in Sydney, Australia. And I love teaching technology and communities. So thank you all for being in my community and being here today. So let's get on with part one. So I'm going to jump into the first part. I want to jump to the first part. Okay. Cool. Okay, so this is our cipher that we are cracking today. Mysterious looking weird letters, etc. We need to find out what this is going to say. You can read this on your own time, but basically I'll sum it up for you, which is this is a hidden message, and it looks like it might be encrypted with the Caesar cipher. That's what these numbers are about here, and that's why none of these words make any sense. I'm going to tell you a little about Caesar ciphers in a second. But first we're going to, just get open into Visual Studio Code and actually just write some Python to get us started. So we only need to open Visual Studio Code. So I've already got mine open here. Somewhere. 1 second. There we go. Let's pop this one on another screen. Cool. I've got Visual Studio Code open here already. I'm using an existing GitHub repository, so I'm not going to actually make a new project today, but maybe I'll do one just for the sake of showing you how to do it, making a new window, super easy, and then I can just go new file, and then as easy as that to make a new thing, or open an existing place and pop something in somewhere you already have some Python stuff installed. Stored some Python files that you've already created. So super easy to get started there. That one can get out of the way now. Okay, cool. So I've also created in my Open Code Garden November month, I've created an IPython notebook. So you can see that right here. It ends in the IPYNB file extension. Sorry, it's called a Jupyter notebook now, but the file extension still is IPython notebook. So every time I read it off the extension, I mess up the new name, which has been around for many, many years. Anyway, but yeah, you can make your own either IPython notebook, Jupyter notebook, if you are using Jupyter notebooks, or you can just make a .py file to do your code in. Basically, each one of these boxes here is just the equivalent of a Python file, but you can kind of run them all together. If you haven't used Jupyter notebooks, I could have a equals 5 here, and I could run that. I could have another one down here, and I could print A. And then they all run together. If you want them to be like that, you have to run them in order, obviously. Super convenient if you have multiple things. Cool. But we're not writing A equals 5. We are doing grab. Let's have them both side by side. Okay. Cool. Okay, so I've got let's pop this away, have a bit more screen real estate. So we've opened a new folder. You might make a file called decrypt.py, which we're making a decrypting cipher. So that sounds like a great name for that. As I said, I'm just using Jupyter notebooks today. So I'm going to make a comment. I'm going to make a box that says what it is with Markdown, a thing you can also do in Jupyter notebooks to make some nice headings. Cool. So now I've got a heading to go above my Python code. So that's what we're doing. Okay, cool. So yes, and you can close that welcome tab now. You don't need it if you've just made a new project. Cool. We do want to check that we've actually got our extensions installed. So to check that, you can go here on the left, and you can see I can look for Python. This is where you install it if you haven't got it already. And we can see that I have this Python by Microsoft here already installed. If you don't have that one, get on it. It's going to be needed. So yeah, highly recommend installing that. And that's the only extension you're going to need for today. So I'm going to close that off now. Okay. Cool. So you can copy this in, or we could write our own print statement. I'll just pop it in because you don't need me to watch me write everything. But I'm going to say code gardeners. And then I can run that. Oop, there we go. But it just prints out there. Super easy if you're doing it in Visual Studio Code. I keep accidentally making new boxes. No. Okay, that's too many boxes. If you're doing Visual Studio Code, you'll see it pop up down the bottom in a terminal window, which is super easy if you've got your Python extension installed. Okay, cool. We've printed something. Great. We're happening. We can keep on going into the next part now. Wants to teach us how to write a comment. So let's do that because comments are super helpful. They're just parts of the code that are for humans to read, not computers. So characters print. What we've got here. Now that part won't do anything. We can just read it. Okay, cool. We've written a comment. We can also set a variable. It would be great to let me know in the chat how much programming you've done before, so I know where to stop off along the way. So say if you're a complete beginner or if you've been, you've done a couple of projects, let me know what you're looking to learn today in today's Open Code Garden as well. Otherwise, I'm just going to do this word for word. So cool. I'm going to make it all Code Garden themed, of course. So instead of saying Contosoville, I'm going to say Code Gardeners, and then instead of having, let's put it here. I'm going to put name, and I'm going to print hello. That's name. You can run that as well. Follow Code Gardeners. Okay, should have my comment back there for grammatical purposes. But yeah, there we go. We have to have that space on the end because it's just going to smush those two things together. But we can see that's been smushed onto the end of there. Super easy. Okay. Cool. Okay, we've got that. Great. We've got our basics done. We can do variables. Very important. Store something, use it later. Much easier than having to write everything out and out over and over again, because I could easily do, this multiple times. And then it would do it 3 times. Yeah. So we've got our variable set up now, which is super easy. And now let's go on to functions. So we're kind of doing a big jump from just getting started to a concept that I guess a lot of people leave till a bit later, but it's actually not very tricky and it's very useful, especially when we're doing something like decoding, but it has a lot of repeated things that need to be done. So we're going to be decoding one letter at a time, where we're going to have to do a specific operation to that one letter. And rather than having that big chunk of logic sitting out, being repeated lots of times in the main area, we kind of want to put it up to the side and say, do that thing that we set up earlier. So that's what functions are for. They're making a little factory essentially where you can give it one thing and it will give you back another thing. So this one is setting up a function that's called chant, where you give it something and then all it does is print the thing 3 times. So we'll start with that. I'm just going to start with this exact function as it is. So we'll put that in. Then we need to call the function. So this is kind of like saying, here's my little factory. And then you need to place an order with the factory essentially. And you need to do that after you have created the function. So define the function. That's what the def is short for, define a function. So I'm just going to use Contosoville for now. If you're like, what is Contosoville? All these Microsoft Learn projects needed some sort of demo name, so they use Contoso as their fake company if they're referring to a company. If you're setting up a fake Teams channel or something, then they'll be in the fake organization Contoso or Contosoville in this example. So we can see here that we've given it this variable essentially. We've said the phrase that we want you to do the operation on is Contosoville. And then all that this function does when it gets called is print the phrase 3 times, and we can just see it's just smushed them all together because no spaces or anything. If we wanted spaces between them, we need to add them in here and add them actually in. And I do have an easier way to make that look nicer if anyone wants to, ask about that at any point. Because yeah, there's lots of new, Python's always, developing itself. So to add new features to make it nicer for everybody to use. But yes, that's just our little demo function there. So let's make a different function, which is going to be, let's call it, I don't know, string reverse, or no, let's say string no vowel. And we're going to get a word or something, and then we're going to say no vowels, no V for short. It's going to be nothing, and then we go for I in, say, letter. Good variable names for letter in Word. Then we're going to say if letter in, not in Word, then no V plus, do the easy way first, no V plus no V plus letter. That's it. And then when we get to the end, we're going to print no V. We can call that function, call it with my name, which has lots of vowels. In letter not in. Let's do this again. A-E-I-O-U or A-E-I-O-U. If it's not in there, that's what I want to say. If the letter's not in there, I've done this in the wrong spot. If letter not in, let's get that. So this is our vowel collection. And whenever the letter isn't in the vowels, we want to say, let's add it to our no vowel string that we're putting together. So, for some reason, this is not lighting up. Because we're trying to define it again. Here we go. Okay, cool. So we do that and we see RN has been printed. Cool. So super easy to do that. And we can, do that for other words. Let's do Sarah's name. We get Sarah with no vowels. So that's kind of what a function would be used for, because you don't want to have to write. Imagine you needed to have something that remove all the vowels. You wouldn't want to have to write this every time you needed that. You just want to put this off to the side, and then you just want to be able to say string with no vowels and just get the answer. Just like if you wanted to use like something like sum in Python, you don't want to have to always make the code that would add all these numbers together, because that would be boring and unnecessary and messy. So we just have these inbuilt functions, but you can add your own functions and just define them and then use them as much as you want. So super easy. So let me know if you have any questions about functions before we move on to making the functions we want to use for our cipher decoding. Okay, no questions? The LA from Woolworths is on mic, but I don't know if you have a question. Okay, well, feel free to jump in, drop a message in the chat anytime you want. And then, I'd love to talk to you on mic. That'd be exciting. But for now, I will proceed on to our Caesar cipher. So we're back to here with our weird message that we don't know what to do with it. So we're going to talk a little bit about Caesar ciphers. So if you've not done any before, in the land of teaching kids to code, I love to teach Caesar ciphers. So I'm not sure how familiar everyone else is. Okay. Yay, thanks, Marco, for putting in the chat that you did the thing and you got your output. Great work. Okay, cool. So, yeah, let's talk about Caesar ciphers. So Caesar ciphers are basically a rotation cipher. So not super easy, I'm going to say. It's like when you think about it after a few seconds, you're like, oh, I kind of get it. It can be confusing which direction we're going, but let's imagine that we have a Caesar cipher and we want to rotate the letters. So let's say that all A's become B's, all C's become B's, and all Y's become Z's, etc. So everything jumps along one letter. And that's how we could turn something like the word, let's put it on the screen so I don't get confused. Say we had the word cat. We want to turn the cat into the word D, B, U. What cat would become with a 1 jump rotation. We wanted to do cat into a 2 jump rotation. Instead, we would get A, C, V. So we just say, okay, this is 1 jump, 1 step, or whatever we call it. A key of 1 is what we'd actually say, or 2, the key equals 2. So that's how the cipher works there. So that's basically, we need to undo what they have done here effectively. And you can set it up so it goes either way. So you might actually say, I think the way that they've set it up is when you encrypt it, you go backwards. So let's say this would actually be a step of -1. And this would be a step of -2. But in this example, they've gone the opposite way around. So I think if you have an A, it would have, we'll do it as we go along. But basically, we can just rotate the alphabet. And that's what we're going to do with code to rotate it back to uncover what these secret messages are. Because they've given us the keys. That's what these mysterious numbers here are. And yeah, so we can just work out what they're supposed to be again. Okay. Yes, let me get an image up for you all. Yeah. Pop it in here. I've got my fake whiteboard set up. So yeah, we can just see that everything's just set up to map to something different. Okay. So back we go. Cool. So get rid of these things that are obviously not code. That's what we're going to do next. But we're going to just start by doing it 1 letter at a time because it's the same operation. So we need a function that can turn n with a key of 13 back into what it's supposed to be originally. I don't actually know what the secret message says yet because I didn't do the code, and it doesn't tell you the answer at the end of this, at the end of the module. So you have to do it to find out, which I think is a very good way of finding, getting people to complete the module, because I'm like, oh, I got to do it. Otherwise, I'll never know what this secret code is. So make sure you get all the way through, which is very nice. So we're calling this lasso letter. Exactly why, I'm not sure, but it's basically like getting a letter and then taking it back to the decoded letter. I do want to jump back actually to the functions because we didn't talk about one thing. So right now we're doing print no vowels inside our function, but I actually want to do return no v, because that's, instead of just printing it inside the function and then it's just gone, you don't have that variable outside the function. I actually want to return the data. So when I call the function, I'm going to say, devoweled word or whatever. You can call it whatever you want. Devoweled, I'm going to call it. And now you have access to it. I could print it. I could print it a bunch of times, etc. And then, yeah, it looks the same, but I could, print something else after it, have access to do whatever I want with it. So that's what we want to do when we do our lasso letter. So we can get the letter back one at a time and then use that letter to build up our decoded information. So let's get started on that. So we're defining a function that's called lasso letter, which is we pass in a letter like we passed in the word before to deval. Now we're going to pass in a letter and the shift amount. So that's that number, that key that we want to rotate it back by. So to get started, we have just made our function, and then we can see that all of the characters in this table. So basically we're going to do this instead of just having the whole alphabet like we did on this thing here. We're going to go via an intermediary. We're going to look at the character number in the, like, it's what's called its ordinate. And then we're going to get that number. So we're going to get its ASCII number. So the letter A is 65 here, the capital A. The lowercase a is 97. So yeah, basically every symbol has a number that is the representation of it. So if I wanted to represent A in terms of binary to store it actually in my computer, we'd say, well, we turn it into 65. That's the number we associate with it. And then we turn that 65 into binary. And then that can be stored on your hard drive or wherever you're storing it. So that's what we're going to do to get the number and then do some maths to it. So we can then do the maths to get it back to the original number. So say we had the shift of 1. We see the capital letter A. Actually, let's start with B because I think we're going to go, no, we're going to go forward. So let's say something used to be a B, but it got encoded to become an A because it has a shift of 1. So they shift it backwards when they encrypt it, and we're going to shift it forwards again to put it back to how it should be. So it was 66 when they encrypted it. They went, okay, B, that's 66. I'm going to minus 1. That's going to take me to 65, and then they're going to turn that into an A. So now we're going to do the reverse of that. We see an A. We go, okay, well, A is 65. I'm going to add 1 to that to get 66. What does that correspond to? That corresponds to B. And we could do that for a larger key. So we might say it's A, and I want to decode it with a key of 5. So we go 65 plus 5 is 70. It's actually an F. So that's what we're going to do. Cool. So let's get started with that. So we've got our whole table there. You don't need to read the table because you can just use to look up something for you. So I'm just going to pop a new window down here purposes, and I can just print out the ordinate of A, the ordinate of N. So we can just get those numbers and we can pop them into a variable, which we'll be able to use later. So we're also going to be using the reverse of that, which is called ch or char for character. So I'm going to, I'm just going to make a little demo. So we might get A is ordinate N, and then we can go ch is the character of A. So we can print out A, and then we can print out the character of whatever that was, which we'll know is N. But yes, we say, okay, we get 78 from this when we do the ordinate, and then we turn that back into a character with N. We could also add the key to that. Imagine it was 3, then we get Q. So that's how we're going to do it in our function. Cool. So in the function, we're going to start by doing it. We're actually just going to use the lowercase version of the letter. I think it would work fine with just the uppercase version as well, because we do see there are uppercase letters in here. And if maybe we want this N to be uppercase, then we want to keep it uppercase. But for the simplicity, they're doing a dot lower before we get the ordinate. So we're going to turn all the text into lowercase, and then we're going to turn it back turn it into a number, and then add the key, and then we're going to put it back together. I should show you also, I have this lovely Caesar cipher that I've prepared. You can still see my camera. And yeah, you can actually build a cipher wheel like this. I built this one for kids, and you can use it to actually do this without a computer to get them to decode and encode things, or you can do it for yourself for fun. That's pretty fun. And set up a little scavenger hunt or something, which is what we do. So maybe you have a rotation of, let's say we've got A, let's say we have a rotation of 2 to C, just got a little pinwheel in the middle of it, and you can just now read off. You just have to decide which direction is encoding and which direction is decoding when you set it up. But yeah, you can just make yourself a little wheel, which is really fun. So yeah, you can just look up cipher wheel online and you can print one of those off. Super easy. So let's get on with our ciphering with the computer. So we've got our letter code. So I'm just going to take that as is. So what we're saying, get the letter, turn it into lowercase version of itself. So our capital A becomes A, lowercase, too easy. And then we're going to get the ordinate. So we're going to get the number. We had a capital A to start with, we turned it into lowercase a, and then we get back, what's it, 135? 97. I don't know where the other number came from. You get back 97. And yeah, so that we're on our way to adding, to getting to our decoded letter. So now we've got that. Let's run it and print it out, because it's always great to test your code as you go. So we're going to need to call our function, use our little lasso letter factory. So I'm going to say I've got an A, capital A, and I want to decode it with a key of 3. But we're just going to see, firstly, the letter code print out. So we've got 97 prints out. Great, we've done that. So now we want to add the number onto it. So we've got the letter code, we've got the decoded code, I'm going to call it. They've called it, yes, they've got letter code and they've got decoded letter code. Sure, we can do that. Keep it as similar as possible. Decoded letter code, and then we've got the letter code, and then plus the shift amount, because we've got 78 here. We're adding something to it. So if we get the shift amount, cool. So we can just say, okay, get whatever we just had, 97. We were shifting it by 3 in this case. So it's going to take it from 97 to 100. And then in a second, we're going to be able to look that up. So let's run it first with that. Oh, we get 100. And then we can turn it back into a character. So coded letter. So we're taking our decoded letter code, taking the 2 of that, and then we're going to be basically done. I'm just going to return that straight away because we've got everything we need there. Decoded letter. I've called it, there we go, fixed. Return decoded letter. So we need to store this. Let's say letter equals this. Okay, cool. And now let's run that. And we get back, we didn't print out the letter. We get the letter D. So we've added the key of 3 to A. We have lowercased it, so it's now a lowercase a. And yeah, we get a B, C, D. Perfect. So we now have our thing that works for one letter. We can see it work for other letters. Let's say S, and let's say 10. Oh, but yes, we do encounter a problem. Let's do a smaller number to start off with, but we're going to need to do some finagling because we get to S with a rotation of 7. And then the problem is if we rotate past 7, jumping forward, we go off the end of the alphabet, which is going to take us, as we saw, into an ordinate of something much bigger. So we don't have it on here, but we see we get to 122. And after that, see, we get into the punctuation because we've got numbers in here as well. But we have ASCII numbers for every symbol that you use on your computer. So we need to make sure if we get to 122, we actually loop back around to go back to 97. So let's take a look at how we're going to do that. Okay, go n plus 13. Wrapping around. So yeah, off we go to wrap around the English alphabet. Cool. So we're going to do this using something called modulo, because we've got 26 letters in the alphabet, and we're going to use that fact to say if you get past 26 in terms of how far you've gone, you need to go back to the start. And we can use modulo to do this because it's a way of finding a remainder. Because maybe someone said you have a key of 150, which is much bigger than 26, and you need to keep going around several times to make that actually land inside the alphabet. So you could actually have a key of anything you wanted, and then we just need to map that to its place in the alphabet. And we're going to use modulo, which works like this. So the way we do that is we're going to look at what modulo does first. So yeah, we're going to say, let's just start with 11 modulo 10. What it does is it says how many times, well, basically what the remainder is. After you've put 10 into it as many times as possible, what is the remainder? So I could make this 21, you still get 1, or 31, etc. Still get 1. If I make this 32, you get 2 left over. And we can do that for any 2 pairs of numbers. So in the example, I have 3 mod 2. We get 1 because 2 goes into 3 once with 1 left over. And yeah, so that way we could say if something had been, maybe we had 27 modulo 26. That way we get the 1 left over. So maybe we started with A and then we rotated it 27 times around, 7 jumps, and then we go, okay, well, that's past the end of the alphabet. Where would that land inside the alphabet? We're going to use modulo. Instead of saying it's like Z plus 2, we're going to say, okay, well, what would that be? It would be 1 after. It would be 1 more jump. So that's what we can use modulo for. But we're going to need to do a little bit of maths to make this all work out, because we need to start with the letter code and then how many, where that is in the alphabet, because we're not starting at 0 like we would in this example. We're actually starting at 97. So we've got, so this part might take a little bit of brain wriggling to work out, but let's start with ASCII A. I'm going to actually call it the inverse of this, because ASCII A rather than ASCII. I guess it's fine. Okay, let's keep it the same. ASCII. So we're getting the A number from ASCII. So I'm just going to set that by doing ORD A. And as we saw before, we get we get 97. And we need that 97 because we're going to always come back to 97. So if we go too far, if we go 27 spaces away from 97, we need to come back to 97. So that's our home base, basically. So let's keep going with that then. So we've got our ASCII. Then we need to kind of get the difference from ASCII, because we want to see how far we have gone around. So that's what this part is about. So let's make another little box below. This part of the maths is a little bit confusing because it gives you a lot of maths in one go, but I'd rather us talk about the maths. So let's do an example. So let's say we had the letter code, which is, let's say we're doing B, C, let's say C. C equals 99, we know, because A is 97, B is 98, C is 99. We'll just go with that for our example and just doing it by hand, basically. C in ASCII is 99. Then we want to find out, well, how far into the alphabet have we gone? Have we gone 2 characters? Have we gone 26 characters? Have we gone 27 characters? Because that's going to be a problem. So we say, okay, Well, what was A in ASCII? We knew it was 97. So A equals 97. And then we can see the difference is equal to 2. And we're like, okay, great. So that's how far into the alphabet we have gone. But if we maybe, so that's easy with how far is the original decoded letter from there, I guess, is the answer. So we're not saying we've done a rotation of that many. We're saying we're currently 2 skips into the alphabet. But what if we add something much bigger with our shift amount? Because let's say we have a shift amount of, actually, let's make this a bigger number. Let's say we're actually working with the letter Y. And I'm going to get it because I don't remember. Ord Y. Okay, let's print that out because I want to know what it is. I can use it in our discussion. I put quote marks on it. All right, freaks out. Okay, got a question from Marco. Awesome, nice one, Marco. Love your participation. Top of the class. Feel free, anyone, to ask questions at any time, but I'm going to keep explaining it otherwise. Cool. So we've got 121. Okay, because we know now 122 is fine for Z. 123 is going to be bad. So 121. Cool. Okay, so we're going to jump forward in the alphabet there. So let's say we've got a key of 5. Actually, let's just make it a key of 3. Super easy. A key equals 3. So when we do our rotation, we're going to say, okay, well, Y needs to jump forward 3 parts. So we go Z, and then we run out of alphabet, but you could be A and B. So we need to get that number because we know B is the second letter in the alphabet. So how do we get from, if we added it together, Y, new letter would equal Y, which we know is 121, plus key of 3 is 124. So we need to take away the big number here, A, where we started off with. So we can do that. So actually, some of the brackets in here are unnecessary. I actually think they make it a little bit more confusing. But when we do the example, hopefully it makes sense to you. So we get to what I'm going to call Z plus 2, and we just need to minus 26, basically. Or take away as many 26s as possible to get back to where we started out. So, new letter. Cool. So we've got our key, we've added that together, that's that part. And then we're going to take this apart. I'm actually going to bracket it differently than they have done it. We're going to get the letter code. All right, maybe that's the same. Letter, okay, yeah. This is a little bit tricky when you're thinking about it, but it makes sense when you think about it in terms of the wheel. Okay, so we get this big number, and we're like, well, this is not in terms of like alphabet because we didn't start at the start. So we actually want to minus the 97. So I'm going to minus 97, which is our original A. Where does it start off with to get us how far into the alphabet we actually are? Okay, we get that. 27, as we said, that's off the end of the alphabet. That's no good. Okay, so now we want to modulo that because that's going to tell us how far around we actually are in the alphabet. So we want to modulate that by 26, the number of letters we have in the alphabet. So then we get 1. Okay, and then we actually start, we're going to say the letter A is the 0th letter of the alphabet, the letter B is the 1st letter out of the alphabet, the letter C is the 2ndest letter of the alphabet, starting at 0 basically. Okay, cool. So now we have the actual letter. That. And then we could just char that to get it back into a letter. But we need to add on where we start off with again. So we're going to add A plus, say, 97, just keeping our thing all in terms of actual numbers. 97 plus 1, we get that. And then we can print, let's just print out, and we'll get the letter that we should actually have it decode to, which is B, which is what we wanted. So hoping that's making sense to all of you. Excellent. Okay, cool. So yeah, do jump in and ask any questions if you want. I'm going to pop in this piece of code, which hopefully makes sense to you all. Cool. Okay, where do you go? You go into here. But we need to define some things. And actually, they do it inside of their function. Where do they put it? They have a whole function here. Let's get that. But I'm going to, they've also put some nice comments in for all of us. Get that here. Okay. We've got that. But I actually think that some of these would be better as constants outside of the function, because this never changes. We don't need to set it every single time we call the function, nor do we need to set the alphabet size, because they are always the same. So I'm going to actually put them above. Whoop. Put them up here and indent them. And I'm going to call it, I'm going to set them in all caps, which is just the Python way of saying this is a constant, because we don't actually have constants or variables like JavaScript. So I'm putting this as a lowercase a because it's actually the lowercase a, so that's kind of important to have be represented. So we put the alphabet size in, and then we're going to put this in here. So we don't need that constant defining inside of our function. And here we go. So yeah, we've got our letter. We've done all of our maths to get the true letter code. So we've done that whole rotation. Then we've decoded the letter with char, and then we return the decoded letter. So that's your tricky line right there, but hopefully it makes sense to you. And cool. So now we have that. We can say whatever we want. So now when we say S is 10, it prints out C, which is much better. And we, as we had with our example before, we had Y and we had a rotation of 3, and we should get back B. Perfect. Cool. So now we can do it for one letter. Super easy. Not quite, well, super easy to call. It was a little bit tricky to write because of all the modulo maths stuff going on. And lots of moving parts. But now we have our function. It's really easy to decode a letter, and that's why we write functions. So we don't have to think about this line of maths ever again if we don't want. So now let's go back to our learning pathway, and we're going to decode a full word. So we're going to make a new decoding function called lasso word. I don't know why they use lasso word, but maybe it makes sense in an American context. Maybe it's lassoing because we're going around and it's a circle. I'm not quite sure. So here we go. We've got lasso word. And we're going to take in a word this time, not just a singular letter like we did when we defined this one. And we've got the shift amount again, because we do need to know the shift for the whole word. So now we want to do this for every single letter in our word, which I kind of did something for everything in our word before above when I did our for letter in word, get rid of the vowels. And that's basically what we're going to do here again. So that's in fact the exact code that's here. So scroll down and just say, basically, look at every letter in the word. We want to decode that letter. So we're going to call our lasso letter function, and it's going to return us the decoded letter. And we just need to tell it which letter we're using, which is the latest letter in the word when we loop through it. So we've got this letter, whatever letter we're up to. We've got the shift amount, which is the same for every word. And then we do need to save that into something. So yes, as we see here, they're like, okay, well, now we've got the decoded letter. We could just print it out here, actually. Let's just start with that. So let us look at our original word that we had. Where is that? Here we go. NCEVY. Okay. Let's give that a go. Call our function. NCEVY. And it had a thing of 13, a shift amount. So let's call this with this word. And the shift amount is 13. So then we're going to print that out. Wait, no, it's going to print itself out inside of the thing because we haven't actually returned it yet. So let's see what it says. It's going to print it one line. It says April. Okay, great, interesting. I wonder where this is going because I have actually no idea. But it's just all like on different lines. It's just printing each letter at a different time. So we actually wanted to put it all together and give us back the word. So instead of printing it like that, we are going to build up our word one letter at a time. So this part is, just like we built up our devoweled name, we're going to build up a decoded word. So, let's take this exact line. Decoded word. We're setting up with the empty string, so it's like this has no characters in it yet. And then we are going to just add on our decoded letter each time we have lassoed the letter. So we get the decoded word. You could do this and say decoded word plus, let's make it tidier. Decoded letter, one at a time, equals lassoed letter. And you could say exactly like they've done here, and say decoded word equals decoded letter. I'm going to give you a hot tip, which is instead of having to write decoded word, when you just want to put something on the end of it, rather than having to say, take the thing and reset it to the thing plus something else, you can do plus equals, and that's going to give you the original thing plus a new thing on the end. So really handy. And then after that, we do want to return, after we've done the whole loop, that is, we don't want to put inside the loop, otherwise it'll just give you the first letter. We want to return decoded word. Cool. Okay, so we can print that out when we get it back. April, once again, but now not on many, many lines. So great. Cool. So it's got all the commenting in here, which you can grab yourself if you would like to keep it neat and tidy. Highly recommend commenting your code. But for the sake of keeping things on the screen, I'm just going to leave it small. And you all were here when I wrote it, so you'll remember. Okay, cool. So now we can try doing other shifts. So it does also want us to print out all the stuff like this when we've done. So let's give it a go and see what that prints out. So it's given us, a new line. So it's saying, okay, let's get a very verbose description of what's happening. Shifting terror by 13 gives us green. Great. So it's giving us the new line character here. That's putting the enter, and then it gives us the lassoed word. Cool. Okay, so we could do that for many different things. Cool. So we've got our 2 different bits and pieces there, and we can just try it for all of the different words to, reveal the secret message. I'm going to actually tell you a little quick fact about how to make this just a little bit neater rather than having to do all these new lines, etc., and adding the things together. I'm going to teach you about F strings. So print, let's just say it in a variable. I'm going to say my name is Renee, and I'm going to say print, and I'm going to use an F string, hello, and then I'm going to put name. So the name of my variable in squiggly brackets, parentheses, no, braces. And then it just puts it in there, and we don't have to worry about the pluses and having lots of quotes, etc. So our variables and make it print out nicely. So shifting word by jump gives us answer. So I'm going to do, and then I'm going to do this one at a time for each word, each jump, and then the answer. So we need to do, just going to copy these words because they're a bit funky looking. I'm never going to remember how to spell them because they don't exist. Ooh. Okay, cool. Jump. You can actually just do, probably just easy if we put them inside there for convenience sake and putting it all together, but this is a fun thing to learn. And let's get the lasso word for word and jump. Cool. Okay. And then I didn't actually assign that to answer. Okay, let's give it a go. So we get April again. We want the new line character. We can have that back again. Cool. So we can do that. And we could do that again for each of the different things. Cool. So I'm actually just going to do it just steal that code because I don't need to write them all out. Okay. Cool. So we've got our answers, which is April 4th Contosoville, which must be the secret answer to the secret village of Contoso. So that's how we make a Caesar cipher. And you can do your knowledge check and get that completionist goal of what's going on in Contosoville. But that's all of the content, I believe. Yeah, and you can check out the summary, but that's the whole thing. Thanks for coming and learning about Caesar ciphers with me. Does anyone have any questions about anything that happened there or any other Python that you're like, oh, I'm so stuck on classes or loops or lists or dictionaries? Hang on the line for a little bit more while we have anything else to discuss. But Sarah has popped something into the chat. Just if you could do a survey for us, that would be lovely. We'd love to know what you think of these events so we can keep doing the ones that you like. Feel free to also drop in the chat if you have any suggestions for things, or come on mic and tell us yourself. Thank you, Marco. I'm glad you enjoyed it. Thanks for all your posts in the chat as you went along. I love to see it. So yeah.
Thank you, Renee. Thank you for your session.
Thank you so much. Thanks for coming along. We'll be doing this again next week. Not next week, the next fortnight. I do have a slide for that. Where we're looking at making quiz games in Python. So come along for that one in a fortnight's time, and we'll do some more of this. We'll do another module, the next one in the Learn pathway. That's it. Unless anyone has any other questions, we'll sign off for today. Okie dokie. Thank you all for coming. And I hope to see you at the next Open Code Garden or the next YouTube Twitch version of In the Code Garden coming up next month. Thank you all so much.